Now it's your turn to factor trinomials using the technique for when the leading coefficient is 1, which involves analyzing factor pairs and sums. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. We're told to factor each trinomial completely, and the first trinomial we'll look at is y squared minus 10y plus 25. So to start, we know that we need two numbers whose product is going to be positive 25 and whose sum is going to be negative 10. One of the key things we can note is that if we have a product that's positive, then both numbers have to have the same sign, so they both have to be positive or they both have to be negative. If their sum is negative, then we know that both numbers are negative. So the two numbers we're looking for here are going to be negative. To go about this systematically, we can make a table that involves the factor pairs of 25, and then we'll check what the sums of each of those pairs are. Okay, so factor pairs of 25, they both need to be negative. We could have negative 1 and negative 25. That would give us a sum of negative 26, which doesn't work. The only other factor pairs we have are actually negative 5 and negative 5, which would have a product of positive 25 and a sum of negative 10. So those are the two numbers that we want. So in using this to factor y squared minus 10y plus 25, we'll write that y squared minus 10y plus 25 equals then y minus 5 times y minus 5. This could also be written, if we wanted, as y minus 5 quantity squared, since that's the same factor. If we wanted to check this answer, we could distribute. So if we check, does y minus 5 times y minus 5? Let's check. When we distribute and expand that, we'll get y squared minus 5y minus 5y plus 25, which then gives us y squared minus 10y plus 25, which is exactly what we wanted there. In this next example, we're going to factor negative z squared minus 7z plus 60. Now the first thing we want to note is that the leading coefficient is negative 1. And in general, if we have a negative leading coefficient when we're factoring, we want to at least factor out a negative 1. So here, we're going to factor out that factor of negative 1. So I'll have negative, and I could write it just as a negative outside the parentheses. So I'll have negative and then parentheses, and then inside there I'll have z squared. So I factored out a negative 1. And then instead of having negative 7z, since I factored out a negative 1, I'm going to have plus 7z. And then instead of adding 60, I'm going to have minus 60, since I factored out a factor of negative 1. Now this trinomial, z squared plus 7z minus 60, is the one that I'll need to find the appropriate factor pairs for in order to factor it. So what I'm looking for now is I need two numbers whose product is negative 60 and whose sum is positive 7. So I can see that one will be positive and one will be negative. And I know that because in order to get a negative product, I need the two numbers to have opposite signs. And then in order to get a positive sum, that's simply going to mean that the one with the larger absolute value is the positive one. So let's make a table of factor pairs for negative 60. And then as we make those, we'll make sure we keep track of what the sum of those factor pairs is. So to start, let's do 1 and negative 60. That'd give us negative 59. We also need to check negative 1 and positive 60, which will give us a sum of positive 59. So not there yet, we need a sum of 7. So we'll go 2 and negative 30. And again, in determining these factor pairs, I'm just looking at what are the factors of 60, and then I know that one of them needs to be negative. So 2 and 30, those are factor pairs. So I'm going to have 2 negative 30 and negative 2 30. The sum, when I take 2 and negative 30, gives me negative 28, and for negative 2 and 30 gives me positive 28. Continuing on, 3 is a factor of 60, so I'll have 3 and negative 20, or negative 3 and positive 20. And those sums, respectively, are negative 17 and positive 17. So I'll continue on. 4 is also a factor, so 4 and negative 15, or negative 4 and positive 15. 4 and negative 15 gives me a sum of negative 11, Negative 4 and positive 15 gives me a sum of positive 11. So not quite there yet. 5 is also a factor of negative 60, so 5 and negative 12. That gives me a sum of negative 7. Negative 5 and positive 12, and that's the one that's going to give me a sum of positive 7. So I can stop at this point. There would be a couple more factors I could consider, but I've got the two factor pairs that I need. So I'll finish factoring, and these factor pairs tell me then that this will factor into z. I have the negative out front, and then the factor z minus 5, and then the factor z plus 12. So when fully factored, negative z squared minus 7z plus 60 is the opposite of, and then the factor z minus 5 times the factor z plus 12.